I had this interesting idea that I wanted to look at, which is, can we make a functional graphics framework? So the core idea is, so I'm going to write this in a Haskell, and the core idea is that we'll have a kind of a painter type, which will take a point on a canvas and it will return a color. So it's a function that if you give it a point on a canvas, it will tell you what color it should be. And a point is another type we define, and it should just be 2 integers for now. And the color, we can make it 3 bytes. So we can say, so we can import the word 8 type from this. Word 8 is just, is just a byte. This is normal thing to use for colors, right? So we can say it's RGB, three colors, like yeah, red, green, and blue. So let's try to run this, see that it works. It didn't like that. Okay, so now you just had to import data.word instead of word 8. That was a bit of a brain fart. But now if I run it, you can see it prints hello graphics, so it seems to be working. And now the idea was that we could define some kind of data type that I'll call canvas, and it will have a list of painters, and then there will be some kind of render function which will take a canvas, and probably the canvas should also have a width. Is it no, it's like this, yes, because it's not Rust anymore. And it should have also a height. And then the render function will take a canvas and it will do a rendering. So I think it needs to be an IO action. And we can just return a Boolean, I guess, like that, because maybe it will succeed or fail. And there are many different ways you can render, like you can render to just like ASCII to std out, or to a file, and it can be like JPEG, PNG, or PPM, or you can just, you know, to a window, or you can open a window on the screen and render the image to that. So we'll have many different rendering functions, and perhaps we would even like to define a type class. But just to get started, let's start by make this render ASCII function. So we'll take a canvas, and we will basically have to loop over the whole canvas, and for each point on the canvas call each of the painters. So it's also quite parallelizable because each pixel is independent by the way we set it up. So let me think about how to do this. So I think maybe, so this do is the IO monad. And then can we like have another do inside, which is the list monad? So we can say like row is 0 to width of the canvas, and a column is 0 from the height of the canvas. And just to see that this actually works, let's try to print a line that says show row and show column. Let's try to, these have to be capitalized. Let's try to run that. Yeah, it didn't like this good match, type this with that. Yeah, so how can I nest? I don't know how to nest monads. Maybe it's the wrong approach. Let's instead, how are we gonna do this? We can, let's make a helper function that returns a row. So we'll do something like let, but we will still need to kind of loop. Maybe if I just say return true here. Now it still thinks that this is an IO monad. This will not work either, right? Okay. So let's make a function that returns, let's call it render lines, and it will take a canvas and just return a list of lines like that. And for now it's undefined. And then here we will do this. We will say let lines equal render ASCII lines, on the canvas, and then we will just put a string of the lines joined, which should be this, and we will return true. So this should compile. So it compiled because we print hello graphics. Now, how do we then render the lines? Well, let's see. Now let's try to use the list monad and see if I can actually get this to work. So for 0 to width of the canvas, let's just return this. Right, okay, we need to remember to add it here. Okay, so that also compiled. And now let's do it like this. Now let's try to call it on something. So we'll have a test canvas, which is a canvas with painters will be an empty list, width will be 10 and height will be 10. Okay, so now it correctly renders the row numbers from 0 to 10. So that is interesting. Let's do this so we actually have 10. And we can argue whether we should start at 0 or not. Then what will happen if I do this? I don't normally code that much in Haskell, so let's do that. Let's actually do this. Yeah, that's what I thought. So each of these will be, each of these elements of the loop will be a separate element of this string. So to join all, and which order does it loop in? It loops in, wait, so we also have a kind of a bug here. This is the column, this is the row, and this is the column. And we want to loop over columns first, which is what we're doing now. And what if we do this? Then it loops the other way around. Great. So we want to kind of join it together. So what can we do? We can say like map take 5. Let's try that. No, that's not gonna work. I want to like group it, so let's make a group function that takes an integer and a list of something, and it will return a list of lists. And I want to do this, I think. So if the list is empty and the accumulator is something, then we will return the accumulator reversed. Otherwise, we will do this, drop in ls, take an ls, put that onto the accumulator, and let's test that down here. Show group in 3, and we will say like 0 to 10. Yeah, so that does exactly what I want. So we can, here we can say group n, and I want to take each row. So I need to take the full width of the canvas. Now I have a list of lists, and I want to join those sublists together. So I guess we have to map concat onto that. Let's see. It didn't work. Can we do that? Okay. So now let's try to do that. This one again. Right. So it is working, but just to make it super clear, I think I want to do this. Right, so now we have everything except that I actually want to write column here, so it's more natural. No, wait, no, it was correct before. Okay. Now, instead of this thing that I have here, let's just comment that out for maybe it's useful later. What I want to do is call the painters. So, and actually, I think a painter should not return a color, because it maybe at that point it will not want to draw anything, so it can be maybe a color. And just to be completely clear, a painter is something like draw a circle, draw a line. That's the idea. So, for example, if we have a circle, it will not appear everywhere on the canvas. So there's no reason to force it to return a color everywhere. And so what I want to do is I want something like map, maybe, I think it's called. And then the function is something like apply painter, and I want to do that over the painters of the canvas. And apply painter, it takes a painter, and I guess it also should take a row and a column. So we'll do like this, and it will just call the painter on row and column. So let's just remind ourselves what this map maybe does. So let's say I have a function here that will do like if x is less than 5, it will return nothing, and otherwise it will return just x. And then I want to say map maybe test function over 1, 0 to 10, and we will print that. Let's see. Okay, it's not in scope, so I think we have to import data that maybe. So you can see here what it did. Let me go down. Maybe we should contrast it with just the map. So map will just apply the function, but map maybe will apply the function and then it will filter out everything that returns nothing. So that's exactly what we want. We only want the colors that actually matter. So here we will get a list of colors. And now we can decide how to combine them. And I think what I want to do is just to take the last one. You could do something where you like layer things on top of each other, but then we have to think about what is the transparency of the layers. So in this case, I just want to take the last painter added. And because Haskell uses linked lists, it's gonna be the first thing in the painters list, most likely. So I'm going to say head or space. So head or space on an empty list should just give a space. And head or space on a color should give, depending on what the color is. So let's actually say if it's a 0 color, it will also give space. But if it is any other color, it will give something that is like a mark. So this is a very simple ASCII renderer. You can imagine doing more things like calculating the grayscale of this thing, and then depending on the grayscale value, you could like return an O instead, or I don't know. You can return different things that you think make sense. But for now, we'll just do this, which is like filling in the square. Okay. So let's see how that goes. And as usual, there is something wrong. Let me put these error messages over here instead. Okay, so the problem is just that we defined a point to be this, like a tuple and not two things. So let's try to run that and see what the next error is. Couldn't match expected type with actual type 3 integers. Right, so it's supposed to be a list, of course. So if we have the first element is this, and the first element is anything else. And it cannot pass that, so we need to do this. Okay, so now it did that. And as you can see, because we haven't defined any painters, it just returned an empty space. So I can also like put an E to show everything is empty. And now there's this very interesting thing that fonts are usually taller than they are wide. So even though we have a 10 by 10 canvas, it looks not square. So we can actually, just to make it look a little bit better, do this. Now it looks more square. Okay. So let's try to define a painter. So I want something like let's try to paint a circle. And to paint a circle, we need a center. We need a radius, and that should be enough, and that will return a painter. So we'll say center, radius, and now we need to return a function that takes a tuple of points, and it will take x and y, and it will return something like if the distance between x, y and the center is less than radius, then it will return a color. And actually we can also say that it should have a color, right? It won't matter right now, but in general it's good to have that. Otherwise it will return nothing, and it should return just a color. So let's see if I can format this a little bit better. And the distance function here will be also we can unwrap this and say and just no wait. So I think we have a square root. Let's yes, we do have a square root. It needs floating point numbers. So just to make things a little bit easier, we will say it's a squared distance. And it will be dx times dx plus dy times dy, where dx is x minus cx and dy is y minus cy. Type signifier for paint circle, yeah, because we misspelled it. Okay, and now here I can say that we actually want to paint a circle of the color. Let's just make a white color. And okay, let's call it circle painter, and it will be painting a circle that's white at, and we'll make here a section what we call test data. Center should be at the center of the screen, so we'll say like 10.5, and the radius should be 3. And here we have an amazing circle. 10.5. I mean, I thought it would be higher up. Let's try this. So something went wrong. These are somehow switched. Yes. They're switched, and also it looks like a square, but we'll fix the square thing later. So apply painter, row, column, and yeah, the problem is this thing. Or rather, let's say row, column, and the row is the Y. Okay, looks more correct. Let's try to see if this square circle is just the cause because of a bug, or if it is because of the low resolution. And now I think we'll have a problem here, but then I want to say width divided by 2, height divided by 2, and width divided by, let's say, 5. Yeah, so it doesn't like that because this width definition here will conflict with the width definition we have up here for the canvas. So what you normally do is you like make a get width function instead. Get height, and then down here we have to say get height, get width, and same here. This is one of the cases where Haskell is not so nice. Where is this happening? Line 56. No instance for no canvas to int, rising from literal. What are you talking about? Maybe it's somehow this that's conflicting, so I'll call the integer division instead. No, that was not it. So it still thinks that width is like a function related to the canvas. Ah, here's a problem. Okay. Great. So now it ran, but it's like, and it's a circle. Amazing. Look at that beautiful circle. Now the real problem is, of course, that because of the way ASCII characters look, it doesn't look like a circle, it looks like an oval, but it's technically correct. So I'm very happy with technically correct solution. Now let's try something else. Let's try render ppm. So again, a canvas and an IO pool, and this will create a file. So actually we need a file name as well. Create a file, write canvas to file in ppm format, and save. Turn true if it succeeds, false if it fails. So ppm is like a very simple image format that's supported by most image viewers, which is why I want to use it, but I don't remember exactly how it works, so I'm going to look that up. Right, so here it is, also called netppm. But here's the ppm, portable pixmap format, and how is it supposed to look? Well, let's go look at the example. So first you write the format identifier. So I guess we will use P3 because we want to use RGB. Then width and height, and then the maximum value for each color, which will be 225. Okay. And then after that, you simply just write the pixels like this, line by line, and it will go in a row major order. Okay, so I kind of want to make the ppm file in a separate function. So like, let's say make ppm contents, and it will take a canvas and return a list of strings. And the idea is that this list of strings will just be like P3, and then the next element is this one. So make ppm contents for the canvas. It will, and let me just, so it compiles. It will assume that we're in this P3 format, so the header will be P3, and then it will be the let's see, width, yes, the width of the canvas, then a space, and then the height of the canvas, and then it will be the maximum value for each pixel, and then it will be something, and that something is quite similar to what we did up here, right? So we do this, we do that, so that we loop in row major order, and each element of this thing will be actually the same thing as up here. So actually I want to make a new function, since we're going to use it everywhere. I want to apply painters, and it should take a list of painters and return a, no, that's not going to work because, well, let's do it. So it should, so what I'm thinking about is, what if no painter touches that area? Then what color should it be? So actually, perhaps we should add like a background color or a default color. Let's do that. And we'll also call it get background color. Why not? So it's a color, and down here we'll say background color is, just to test that it works, let's make it blue. Right, so then I also want like the default color. So we have the default color, and if it's an empty list, it's just the default color. Otherwise, if there's nothing, and we also need the point, of course, where we are trying to that we're trying to color. Then I want to say, okay, so the point and the painters, and then we kind of want this head or default. So actually we need this default anyway, of map maybe, of apply, and I forgot the point again. Apply painter at the point, painters. So apply painter, it takes a point and a painter, and it will just call painter on the point. And head or default on an empty list should be the default color, and head or default on something. And again, I think we need this. Is this going to be the first element? So I think that works. Let's do this for now. Yeah, still runs. And so now we can just fix up this function, and we'll say apply painters with a default color, canvas, get background color, so we won't use this, but actually maybe just for this specific case it's not so nice. But now we have this. It will be useful for other formats. Okay, so I want to apply the painters with the default of the background color of the canvas to this point, which is going to be column row on the painters of the canvas. And then we have to turn that into a string. So we'll define a new function we call color to string. And it has 3 channels, red, green, and blue. And it is very easy. Do like that. Let's see if it runs. It runs, and now I want to test something. Is there a join function in Haskell? Let's not do that right now. Okay. Apply painters, color to string. Great. So now we have the ppm contents. So now we just have to write to file. Let me look up how you actually write to a file. Okay, there literally is a function called write file. So we will write this to, and then we have to combine the lines of make ppm contents on the canvas. Let's see if it compiles. It does. it's not called write to file, it's called write file. And it's I'll do it like that. Great. And now let's test it. And I want to render to test.ppm. Let's do this. So saving was successful. Great. Test.ppm. There's a lot of green. And here's some coloring. Let's change the color. Let's make it kind of purple. And let me try to open this ppm file. Right, so here it is. If I open it in windowed Emacs, then it will actually show us the contents. It doesn't make the image bigger for some reason, and it kind of looks like a Japanese flag with weird colors, which is exactly correct. But let's try to first of all, let's do this. And then we go in here, we say revert buffer. And what if I write 0? Okay, so it's kind of working. This color could be a little bit darker. This color could be this. So we have the framework now to draw things, and now we can make it square to make it look better. It says, let me just try something. Okay, great. So here we go. We can use the same canvas and render it in different ways. And then you can add multiple backends. Right, you can render ppm, or you can render ASCII, you can render PNG, you can render to screen or something like that. So I think this is a good beginning of a framework. Now the only primitive we have is painting a circle, but you can also, of course, implement printing a line or something like that. And maybe I'll look at that in a different video. Okay, see you next time.